Thank you for the introduction. My name is Guillermo Bernal. I finished my PhD in December, but officially graduated this past June at the media lab, as Brian said, Fluid Interfaces group, where we've been focusing on building technologies, pretty much like the ethos for this group, and like where you look at technology, you look at sleep, you look at neuroscience, and you're trying to understand how we can remove some of those barriers that kind of have existed, and maybe open up new venues and opportunities. So we have a group of people that we're good at building tools about moving through these different disciplines, and we can begin to rethink how we approach this. So when we started to look as a group how to engage with, and these are my collaborators. Sorry, I meant switch slides. My advisor is Patty Mays, and I've been working with the visiting student Malika Chiver from BITS Pilani. We've been collaborating with the universities like Harvard University as well as the University of Montreal. But we've been asking for ourselves, is there a way that we can improve the way in which we comprehensively collect sleep data without increasing the burden that goes into the person wearing the device and the person that is trying to collect all this data? So the pandemic, I was talking with Brian early on. The first time that I met Brian, Fascia was pretty much something that you would use only in the lab. It still would be comfortable. A lot of the sensing was the same, but it was very much lab focused. And the pandemic kind of just threw this wrench at us, in which bringing people into the lab was not possible. Be able to move the PhD forward was not very feasible. But we started to realize that a lot of the technologies that we were building. So yeah, when going back to the idea of the pandemic, kind of put us in perspective on how we leverage the technologies that we have and how we can be able to allow it to reach certain communities or certain people. They might be apprehensive about coming into a lab and being and sleeping in a place where they are being watched. So this is kind of the standard of, for those of you that haven't experienced a full polysomnography. This was conducted at Stanford University a few years back. And this YouTuber has some sleep disorders, so she had to go for a full PSG. And kind of, you can see on her facial experience, like she has a need, obviously. She wants to understand her disorder. She's putting up with all the things that have to go on because it's really affecting her life, but it's not the best thing. And as you start to talk to people, you start learning that these are challenges that go on the participant, but also on the sleeper. So taking part of this program on the NSF, the I-Corps, big part is like going and interview people that are working in the space, that are trying to really understand what are the pain points, made us kind of step away from just what we're doing in the lab and starting to talk to other people like Brian and other experts in the field that are working within labs and clinics, as well as industry and so on. And we started to realize that some of the challenge is the stigma that can come with being able to share that you have sleep disorders, how you feel of someone watching you while you're sleeping. That seems to be a big problem why some people don't go into a clinic. The idea that is something that is going to be very uncomfortable, and as we all know, a bad night of sleep it doesn't only affect us the day after. It can even be 2 days that we're really feeling that lack of sleep. So we started to kind of get a lot of this idea. Then we started talking to the researchers and understanding that for the researchers, it's also limiting. There is like economic components to this. When you're paying people to come and do a study, they take the device and they don't really follow the protocol. And then they return the device, they expect to get paid, and there is no data there. So it's a misallocation of resources. There are populations that might not be very technological savvy. So with some of the solutions that are there for at-home sleep studies, they might not be able to follow the right steps and not get the right data, because a lot of these devices, they just kind of load the data into the device and you have to drop them off in order to see that. So we started to just kind of understand more, how can we build something that is familiar for populations that might not be so keen with different applications, technologies, so on. We wanted to make sure that the comfort level was our priority. We wanted to build something that is not going to feel like you're really wearing that is um, that is very different from what you normally do. Understanding that by putting this device, we're already doing that. But if we can make it as comfortable as possible, as simpler as possible, we can increase the adherence on experiments by up to 70%. And those are some of the things that we're seeing and we're kind of reporting. So the device that Brian was mentioning early on, the Fascia sleep mask, provides up to almost 80% of what is required to be considered a level two level two polysomnography device. A level two will require still a chest strap for if they're looking for sleep apnea. Our device, we cannot do the expansion of the lungs. We can measure respiration through like the accelerometer and gyroscope. We can get blood oxygenation through the forehead arteries and so on. And as I was mentioning earlier, we're kind of looking into being able to go through certain points which you can get information for validating certain type of experiments, working with experts like Bob Stickle. They have series of experiments where like getting data from like the midline and the occipital region is very critical for some of the different analyses that they're doing. So we're trying to make sure that those levels of signals were present, as well as that we can do a full night of sleep, meaning that our device should be able to run for at least 10 hours per charge. So you're not, as the device begins to get depleted, you're not compromising the signal quality towards the end of the night. But like the mask becomes just mainly like the main apparatus to just kind of get insight from the device. Then we built a portal that allows us to manage a lot of the complexity that it goes into running these sleep experiments. One being like, how do you manage your expertise, your experiments, your different groups? How do you anonymize the data, remove any sensitive data, and then you're still able to get that insights from understanding, is the person running the experiment correctly, or are they missing something? So the device kind of the portal gives us a lot of those insights. So there is a lot about privacy layers that we have implemented. Here's where we allow to interact with this hub that I'll mention later on. But more importantly, to give you like the tools and the things that you're expecting to see when you're running a sleep study, meaning like your filters, when you're doing a stimulation, is that getting time logged? All the markers and everything being associated, who has access to this data and who's not. So a lot of the objective was, we're not going to be a level one just because the level one requires for a technician to be present. But we can be very close to be a level two. And the way that we can get even closer is by having this hub where allow us to get information about the environment. So in this case, we add an infrared camera. We have a view on the object, on the person that is wearing the device. The microphone and the speaker allows for this bidirectional communication between the person and the person running the experiment and the subject, and also allows to do stimulation. As you can hear right now, that little sound, if you're able to prompt and see like, okay, can we see a K complex? Is the person specifically at this stage, or are we going to provide like pink noise or some other type of stimulation? Now you're seeing, I don't know if you can see on your screen, it's very faded, but the atomizer begins to release the humidity levels are increasing into the space, and the oils that are in the liquid begins to get present in the room. So now you can begin to do things related to like memory reactivation and consolidation. These are all different areas that our lab was working on at the time that I was part of my PhD. So there was different layers, and we saw that we could provide these tools, this leverage for researchers that are interested in interacting for neuromodulation with the person at home. In all the criteria that is when you're doing this work is that your data is well aligned, meaning the stimulation and the response of the person should be within the milliseconds. And that's what the hub kind of is doing. We have the hub only has one button, as you can see right now. Is that is just for privacy. They're not able to collect any data from the hub until the person presses that button. This means that they are asleep to wear the device, and therefore we can begin to record. We want to be sensitive that we're not recording something while they are changing or they might not be ready to do those kind of things. So user privacy was a big concern early on. And as I move along, yeah, so here we can kind of see a little bit more a breakdown on the on the on the different capabilities with the hub. When we started looking about the microphone, the speaker, we started to thinking a lot on like how do you begin to interact with the person dreaming, like when you begin to prompt them to dream about something or to give you the report of what they were dreaming. If you're interacting with them, we like for example the hypnagogic state, which is a lot of the work that Adam in our group has been exploring in order to like steer as to how people begin to dream. We can then do like speech to text to kind of transcribe that information, but have like those capabilities to do that in a very seamless way. As I mentioned earlier, being able to lower those barriers or those interaction points where the person has to do something else besides what the normal what you would normally do when you're dreaming is like our priorities. Make something that is almost not present, but present in order to interact. As I was mentioning before, the portal allows us to be able to run multiple experiments at one. We can deploy multiple devices at one. So you're now just limited by the number of devices that you are able to get and run at the same time. But the portal is allowing you to manage all the different components. You're taking your notes, you're administrating anything that goes into like running these experiments. Right now, currently, what's the solution? You just have folders within folders that you're kind of managing all these things. Here we give the right layer and the right layers of security. Some are that can meet the HIPAA compliance. Those things are very expensive to run as you begin to deploy on those containers, but accessible for us. So something that you can choose as a researcher what is allowed or like your grant or like institution. So yeah, so as we look into the portal right now, one of the things that we very early started to learn is that registered polysomnography technicians and sleep experts are used to seeing data 30 seconds at a time. And we were building this. It was like, this is going to be a good way to collect data to build great machine learning models for us to be able to predict certain things and so on. So we want to make sure that we can see very granular. An assumption that when we started to put this in front of technicians didn't work out so well. So we started to learn from that, and something that we're still doing by keep learning with what are the tools that people really need, what are the mechanics that they're used to, and so on. But yeah, so as you can see here, this is like what you would look when you're running a live session. You have the device that are connected. Each device have their own device address, their own serial ID, and so on. So only those people that have access to these specific devices can have access to the data, and they're part of the specific device. The specific experiment. Everything that is on the right is more is meant to be used with the hub. See if you want to interact with lights, if you want to interact with sounds, temperatures, and as well as filters, you can kind of interact with that. On the bottom is things that through the API you can build your own button, your own functionality. And then on the very bottom is giving you certain information about if you want to understand about the states of the user. So models that we're running can be there. So in this case, although it says awake, that experiment in here, actually we were already seeing N3, and what we did, we just we were N2, excuse me, And we play a sound, and what we saw early on is a K complex, but in the shape that is being displayed right now, it's kind of being elongated and kind of squashed because of the visualization. So which is something that I kind of send us back. Okay, we need to rebuild our tools in order to understand that people are expecting to see something in a certain shape, and they're accustomed to see data in a specific way. They should be able to see it in that. Otherwise, you're not being able to understand if what you're seeing is what you think it is, and so on, and which is defeat the purpose of the whole real time thing. I give you a lot of information more on the process of how do we develop this than the device. I figure that that has more value. For example, this is a spindle right here. You can see, if you count, you will see about 15 to 16 peaks, which is how they appear. But they look a little bit more stretched out than what you will see in like a textbook of how a spindle will look like. Um, uh, we understand that when it comes to sleep studies and sleep analysis, we have a very different type of population. We have people that come from more the psychology and theory background that have a lot of knowledge on the theory and the maybe not so much on the technology. And then we have people that are approaching sleep mainly from the data science, and they want to be able to just access the raw data. So for us, it's being like an interesting process to understand how do we build the tools in which, if we're saying we're going to provide this for the sleep community, we have to understand that the sleep community doesn't mean that it's only someone that comes with a specific like neuroscience background or cognitive or psychology, but it has to be something that can really service these populations at different levels. So we have done a lot of interviews, put this our portal and a device in people's hands to understand what are the things that work for them, what are the things that we've done, what are things that are expected to have in order for them to be able to work with that device. I think the ability to have this hub where it becomes essentially an IoT platform that people can just put through different modalities of intervention seems to be very interesting, something that the community finds very interesting and appealing. But when it comes into like maybe when we lead too much into like how we do the data science and how we're managing the data, there might be a little bit of pushback because people already have like tools and certain things through MATLAB or other software that they're using EDF file or they're using specific resolutions and so on. So going through this of like the constant process of presenting the device, presenting the tools, learning from that, and then assessing is something that we keep iterating back and forth, and we're still doing that. Overall, as we begin to understand and ask how easy or hard it is to use, we get like positive feedback. A lot of the challenge comes when it comes to the capabilities. Like there might be, if you're working with like Sandman or your PSG, you might be you might want a lot of those tools, which at that case, we don't have those 10, 15 years in which those software been deployed. But when it comes to a lot of the new uh, features and new devices that enable to do new things, uh, people seem to really agree and kind of like some of the capabilities. So it's just that compromise that we have to figure out. Okay, so where does our tool really fall when it comes to like the traditional uh, sleep analysis tools that exist and the things that we can provide to them? Some of the things that we have done, and you might have seen the paper that it was sent out, is that we start to look into how each one of these markers that are used right now to understand whether you are in stage N2 and N3 and N4 compared to those existing devices and database out there. The goal for this is more saying our tool, our device is able to provide this, saying that we're doing it in a much better way or like it has a better resolution, but more like this is a tool that if you're trying to use it, it will give you the markers that you need in order to do sleep staging. We're looking now like as we go like into N3 where we're looking into something like slow waves. Are those slow waves present and what channels are actually being compared from one to the other? sometimes can be tricky because each device in different companies use different montages. So our next pilot running is where we have people wearing fascia with a PSG at the same time in the same locations, just so that we can do a better apples to apples than what we did for this iteration of the what we call the verification of our system more than validation, because we're just verifying that all those signals are there. I think that the thing that for us is more promising and we find more excited about is that when we look at things like sleep onset, when spindles begin to occur, is doing what we were hoping, where the device is not really adding a layer of discomfort or that is presence is felt by the person. The sleep onset begins to appear within 8 to 5 minutes within. And this is with the people that don't have any sleep disorders, just to be clear, which is another thing that we need to do later on. It's like, can we provide full markers for someone that has been diagnosed with insomnia, for example? Does it perform the same way? Some of the things that we're working so on. But we understand that when we look at things from the tools that are appearing into the world, like these models that are transformers that are able to perform so well with different other tasks, the data, it's hard to understand how, as a field which we rely on these time series data, can really begin to leverage a lot of these models. If you look at the largest that exist out there that are open to people, the sample size and the abundance of data versus like the audio, image, and text, that is the ones that are making the breakthroughs into like what we see in the GPT and image generation and so on. The only way that we can begin to develop that much data if we as a community begin to work towards building these repositories where data is being well labeled, it's marked, it's usable, and people can begin to add on top of what is existing. And I think that's kind of some of the infrastructure that we're putting right now with Fascia, is just mainly focusing on like, can we develop the repositories where we can expand the work that we're doing, someone else can grab it, build on top, add to that data, replicate, and so on, in a much more seamless way. Yeah, so just to wrap up with the Fascia ecosystem, we're able to provide stimulation through sound, smell, humidity, and lights. When this lights is when of course the sleep mask is not on, and we're able to send brain signals through the form of EEG, EOG, eye movement through EOG, heart rate through a PPG sensor that lies on the forehead where the main artery is, and we look at electrodermal activity that gives us insight into arousal. You can begin to use this type of information for affective type understanding. Is a dream a positive or negative? That can be compounded with the heart rate and the skin temperature as you look more into the affective research world. Muscle tone not only is useful to understand his atonia, but also as people are dreaming and they're frowning or moving some facial expression as part of their dream, can give you some insights into the dream. Respiration, we measure it through the accelerometer, and the motion just to understand body position and respiration. The monitoring side of things is the one that kind of brings everything together, where allow us to see the data in real time, make sure that our experiment is run or the way that we intend to, and also that we're able to intervene at specific times. So you can schedule things, but you can also say like, I feel confident that the person is in a specific stage, so I'm going to stimulate now. Playback is all about just kind of seeing your data. The part of the data, the playback is that you can begin to tag information. We do a lot of the other things that you don't think so much when it comes to like sleep monitoring, not just the signal, but it's like, how do you bring all this data together? So it's like, I can say what's your control group, what's your experimental group, how do you make things that are not, that you can de-anonymize some of the information. I didn't show like the hypnogram and the machine learning, but those are things that just kind of we're running back and using I where was I had a slide, maybe I had it hidden, or maybe I removed it, but essentially with the machine learning, we're just kind of creating a capability where you can just kind of tap into some of the existing models. So being like YASA library access, we give like the deep sleep. We have a regression model and some other things. So the idea is to make it easy for you to plug your own model, to use some of the models that exist out there, and to use it as a way to validate your system or keep improving on some of these other systems. Yeah, I think this is maybe a good way to, if there are any questions, to just kind of go over them.
Awesome. Yeah, thanks for the overview. Like all really interesting stuff. And if people have questions, you can feel free to either put it in the chat or just you can just go off of mute. I'm trying to see if there is a raise hands. I think that's under reactions. You can either raise your hand or put the question in the chat. So yeah, I think we'll just hop right into it and bounce around into some questions, see where the conversation goes, and I see Dr. Ken has his hand up, so we'll go there first.
Yeah. Wow, that's a really cool device. I've worked a bit on a sleep mask with an engineering group, and you guys have got like so many layers there. It's really impressive. One thing I find kind of confusing is the name, like fascia. Makes me think of like the muscles, that are under our skin, or like So why did you end up with that name? Because it seems like you could pick a better name that would better capture what it's really about.
Yeah, it's interesting, and I think you're not the first one. Actually, people that come more like from the field that have worked through like muscle structure, either because they were athletes and working through nuts and all these other things, they come to that. I think fascia itself is an interesting organism that brings a lot of things together, that protects and distributes certain level of information across our body. But also there is fascia not just from the body. There is the architecture of fascia, where it's like this outer part of the building, this outer layer that kind of protects all these other channels. So it was just kind of a name that was like, okay, this kind of works for like the idea there is something within our face, that there is this network of signals and distribution that is happening. He just kind of stuck with it. We just kind of went with it. And now, yeah, I think that when someone hears it that it doesn't know about tissues, they kind of they like it. The person that knows about tissues is like, this is about muscles, nuts, and so on. So yeah, we always get either perspective. Someone says the name is memorable. Yes. Yeah, we get both of those.
Yeah, and you shared a little bit about next steps, but curious if you could talk a little bit more about that. Sounds like verification, along with polysomnography, building a repository of labeled data. Can you talk a little bit more about like kind of what you're thinking as far as like the next steps to actually get this in use with researchers?
Yeah, I think we have, as I mentioned, we've been doing more interviews, meeting with other researchers, understanding what are the limitations. So the next thing that we're running right now, we're running two pilots, one with the Boston Medical Center and the other one with the University of Missouri. The one in University of Missouri is more like continue using fascia as it is, and kind of reporting more on like the different type of intervention and recording. With Boston Medical Center, they are the ones putting it with a full PSG. So this is like more like, okay, now you're looking for these specific markers. What does a Cutwell system with our system on top next to each other, those signals, are they in parallel? Which is kind of like what the companies that want to use, for example, we had a meeting with Takeda, and they want to make sure they understand that as they're doing their clinical trials to understand how drugs are affecting people, that the device is not doing something that their drug is not doing, so that everything is valid. So they want more validation on those things that that the system is good. On the other is like, okay, how do you begin to do like all the other things with neuromodulation and how patient adherence? Can people keep using our device even though when they are not getting paid? So that's kind of one of the testing that right now we're doing. Like, okay, if you're getting at $32 for a sleep study, it's a very different incentive than if you give you this, you're gonna sleep with this mask for 12 nights and see if people keep using them because it's not affecting them, or because there is the incentive of the $13 that they keep using them. So those are the kind of validations. Other things that we're discovering is that the fact that it's a sleep mask, if you're doing sleep researchers, sleep study, can be considered an active intervention, meaning that the darkness of the sleep mask can become something that is improving the sleep. So some people say like that's good because that means that people are having a good sleep, then they're going to stay with it using our they're going to stay in our study. But for other people, they're like, okay, so how do I account that as part of my experiment? So that's a big question for us in like, do we need to rethink the shape, or do we need to have a way in which light can be brought into the eyes if as if there was no layer covering that? Question that we still don't have an answer because we keep getting, yeah, it's like something that we're wrestling with that right now, which is different when you are like a consumer product, right? That consumer product, you can say, we're gonna make you do this, and therefore you need to have this sleep mask. I think when we're using it as a tool, then you have to be a little bit mindful on that.
Nice. That makes sense. And yeah, Dash, I don't know if you had your hand up before or you're just if that was just like a mini. Okay. I see Laura's got a question in the chat. So Laura, feel free to unmute and ask it, or I can just go for it.
Yeah, my question is about you mentioned a lot about how it can benefit researchers and people with sleep disorders, but I was wondering for those of us that are not yet advanced enough to do like lucid dream studies. I know Dash has done some of that has been a participant on that end, but I'm not yet as qualified to participate in that kind of experiment. But would this be available on the market either now or in the future for like individual use? And just or like working with directly with like monitoring your own like information, or is it just
Yeah,
that's I was wondering if that was a potential goal.
yes. So as we're moving into, I'm being right now this summer, I'm taking part of a accelerator at MIT called Delta V, and the whole idea of this accelerator is to help us figure out non-business minded people, how do you translate your research into the world, right? And a lot of the things that I've been doing is to understand, okay, so what's the next step to take these things out of the lab? The first one way is, okay, this is going to become a medical device. Then that means that we need to go FDA approval. You have to do your clinical validation. You have to do all these things. You need a lot of money, which I don't have. Made in VC's money or all raising money, they want to be able to get traction, which medical device, you're not getting any traction for a while. So what's the other option? The other option is like you go consumer product where you say like, we're going to make you sleep better or do all these things, which I'm more like, I don't want to be a snake oil company. I want to say like, if we're going to do this, we're going to show you what, because we've done all this clinical validation. We've done all these trials that kind of can say that we have proof that, or some sort of validation that we can do something. So by positioning it right now as a device that can be used for research, we open it for people like you that you might want to say, I want to try this, I want to use it, but we're not specifically saying like, let's go to Amazon and we're going to sell it to you. It just means that some people that want to learn more will go and get our device and can buy it from our own like e-store that we're going to generate. But our person that we're going to go and trying to sell it to is going to be those people that have the need, which is the researchers right now, right? So a lot of researchers don't need a FDA approved device. They just need a device that is safe to use for the subject and that it gives you clinical or like clinical like signal quality for your experiments, so that you know that you can actually do science with this device. So that's kind of like the lowest entry barrier that we kind of figure out right now, that we can do the next step where we can leverage the community that we have, but we can also learn that people like you, that we can figure out, okay, so what are the things that we need to do? So when we're ready to say, we're going to help you, your sleep onset to be increased by providing this type of stimulation, or in the case of lucid dreaming, if we need to build a modality for that, we can understand how and when we integrate that. So those are kind of like the steps that we're thinking to do, and this accelerator is getting us in, teaching us to kind of think about those decisions as we transition from the lab into the real world.
Thank you.
Yes, I think there's a hand raised.
Yeah, Dash, go for it.
Okay. Hey,
Hello.
is this on the market yet for researchers?
It's not in the market for researchers yet. So as I mentioned before, I finished my degree in June. We just found a manufacturer that can help us do the beta units. These beta units are just going to run for the validations that we're running right now. So they're going to be handed off to these sleep centers. Once we have that validation, it would say like, okay, we can these devices are good, they're not breaking, then we can start saying, okay, people, we're going to build 100 devices or 200, then anyone can come and buy them. But we don't want to take money from anyone right now where things might be breaking, like we're still at that like prototype phase. In order to get into way to manufacture, we need to figure out how to make designs for manufacture so things can be streamlined. We can figure out how to lower the cost. Right now, we're not thinking about cost when we're building. We just build it like we want to make sure that this is give us the best. So we're gonna starting this fall, finishing this program. I'm switching gears into understanding how do we get into that part, which is a very different hat from being like a scientist now into understanding how do we make a device that people will use it and they would actually get something out of it. I don't want to build something that it will just live in someone's drawer and use it a couple of times and then they're not happy about it. I think that would be very sad to build something that is just going to go into a landfill in a year or two.
Makes sense
Okay,
to me.
cool. Thank you. There.
Yeah.
I think Dr. Kim, did you have a question?
Well, I ran a sleep study at Acadia, which is in Nova Scotia, Acadia University. We did one last term, and we're doing another one this term, and we're using like a single device, so it's really small, a home polysomnography device, and it's got a lot of the limitations that you talk about, right? The device, you put it on, but you only collect the data at the very end of the night when the person's woken up and it syncs. And so really to be able to collect in real time would be way more interesting and flexible. So I really think that, there is a big need for this. And it also seems to me like you actually already have everything you need for polysomnography already in the device. If it's got EEG, EOG, and EMG, it already is a PSG machine. So
Yeah. It is a considered level. Our goal is to be certified as a level 2 device.
Yeah.
Yeah.
So,
What
I mean,
that-
I think,
sorry.
I guess what I was going to ask is the price point, like, are we talking $3,000 or do we even have a number?
Yeah, I mean, I'm hesitant to give a number because everything that we have right now is to build 10 to 30 units, which you don't tap into like the price breaks that you get once you start manufacturing things for the the thousands, right? And also everything right now, we cannot, since we haven't done the design for manufacturing part, we don't know how long it's going to take for giving the different parts to someone, start assembling, and then give us that price point. So we can say, yes, our BOM right now is $400, but and that's just with the current price point. But that part where we have to pay someone to then assemble all these things, I don't know. But my goal is that this thing is something that is accessible. So what are the competitors out there? One, the Muse, the Dream, and some other devices. So we have to be within those ranges, understanding that we're going to provide something better, right? I'm not going to say that we're going to be the same. Of course, we're going to have something better. But yeah, we cannot be in the, like a PSG right now, like a full PSG is $20,000. I think the actigraphy, one of the higher ends are in the $4,000. So how do we in a place that we can compete? What it can be in a place where people would be open to try it, would be willing to use. And for us, it makes sense more like if we can get people to use more of them as opposed to put it at a high price point where people just buy one. I think being able to understand how do we, as I said, figure out ways that we can collaborate with people, that we can share data, building open source data sets is where I would like to kind of see where the field can leverage from them. We can leverage from those insights. So that's kind of the business kind of model that we're trying to formulate.
Yes.
Yeah.
Sounds like you're kind of going in between the Muse, Dream 3 kind of position and then the traditional PSG, which are still pretty cumbersome. It's like, seems like there's a lot of space kind of between those kind of categories.
Correct. There's a couple questions actually on that and before on the stimulation. Maybe I can share my screen again.
Yeah.
So what constitutes a level 2 polysomnography? In order to be considered a polysomnography, you have to be able to provide brain signals, muscle tone, and as well as your heart rate levels of breathing oxygenation, and the motion, body positioning is the other one. So hope that answers that question. Another one was on like how do we provide the smell and humidity. So you see here there is a piezo disc in here that creates a like a fast vibration that breaks down the molecules of water and then creates like vapor. And then because the oils are in the water, then they release as a smell. And you might have seen like those humidifiers that are out there. It's the same principle.
Every time I see that robot, it brings a little smile to my face. There's something charming.
Honestly, it was not purposely built as a robot. It just kind of, as things were added into it, it kind of came as a cute little Wall-E-like robot.
I like the end result. I see Ryan's
Yeah.
too, but quick related question on the smell, because I was curious about that too. Is that what's kind of the primary use case for the smell? Is it like memory reactivation or something else?
Yeah, it's mainly for memory reactivation and consolidation, as well as we started to look into bruxism. Bruxism is when you're clenching your jaw at night. Awesome, very early research, and we only found like one paper where bruxism seems to be a behavioral condition. So if you're able to provide negative feedback to the bruxism stage at night, that might be a way for you to start interacting with the person dreaming to release that jaw clench. So that's something that we wanted to kind of explore. So we figured that would be a good thing. The tricky part is to really find the smell that is uncomfortable for you, but also that it's not going to make your room smell something that you don't want to smell throughout the next day, or your partner is going to be unhappy. But I think it's a very interesting. It's a thing that I'm trying to figure out because I'm going through it. All this stress has kind of like add up, and I'm like clenching at night and have to use my mouth guard. So it's something that I'm trying to figure out how I can cure myself.
Yeah, but I get where there'd want to be a balance. You don't want a skunk smell every time you grind your teeth. But yeah,
exactly.
So yeah, I see Ryan's got his hand up, so we'll go over to Ryan next.
Thank you. I assume this is on.
Yep, we can hear you.
Awesome. Good. Shortcut worked. So I was thinking about, because you're talking about not wanting it to be like left in a drawer, want it to be something that's usable. And so that got me thinking, what is your idea on longevity? How long are you expecting a device like this to last in like frequent use? So what is your idea on how long one of these devices, say it was in a lab or say it was in someone's home and being used regularly, how often would you expect this device to last?
Yeah, that's a good question, and I think that opens in like two different conditions, right? Like if it's a lab that you're passing it from person to person, you might want to have something that, if you're hoping to run an experiment, maybe a pseudo, maybe not so longitudinal, but let's say you want to get like month or something that can last that long, like a full month of use. But then you can remove them and being able to swap it and pass it to the next person. At home is different, right? Because now you want to be able to use that device for a longer period of time without having to replace these parts, and then with ways to clean them and wash them. So that's something that, and also as a company, and maybe here I'm giving away too many things, but because this is like for the sake of like learning and we're all sharing, one of the things as a company that they want us to figure out, how can you bring revenue? So one of the things that bring revenue is when people have to buy like these little things here and there to replace them and to keep them in a healthy way, right? So that can be a way for us to be able to say, okay, yes, people don't buy this device that often, but they have to buy these things in order to get the best signal and so on. But yeah, so you might be able to spend like $5 for one thing that is only one use, or something that is like $30, but then you get like, you can use it for a whole month or 2 months, because you're improving the quality for that, how long that device is going to use. And that's kind of like a lot of the things that we're going on right now that we're trying to figure out. Okay, do we focus right now on like the first people that are going to start buying the device and we build something for them, or are we building something from the get-go that is going to be able to get us to all those other people that might go and buy it down the road? And all those have like money implications, right? Dollar implications when it comes to like those decisions. So yeah, it's a little bit too early for me to say one or the other, but just kind of give you a little bit of insight in how like those decisions kind of come on that. I am happy to hear any thoughts on how people feel about this thing.
Makes sense. I know at Aura, you know, when I was over there at the Aura Ring, we'd think about like usually 3 to 4 years for normal use of a device, but that all depends on what components you have in there, like how long does your battery last, and you know, still retain a charge. So it's going to be different depending on, you know, obviously what device you have and what components you have within there. I know we're getting close to the 1 hour mark. Any other questions people have, either in the chat or if you want to just raise your hand? We can kind of do a last call for questions, and then I will leave the Zoom open too if people just want to chat, you know, informally. Usually I got a few people that just want to talk, you know, after the you know, kind of primary topic. So I'll definitely leave the Zoom open after this too. But yeah, Guillermo, anything you haven't said yet that you wanted to say, or any kind of parting thoughts?
Yeah, I think I should have a slide out how people can reach out to me, but which I didn't. But I am putting it in the chat, so I'm putting my email. If you want to get in touch, you want to collaborate, there's a lot of work that we still needs to be done with Fascia. If you find this interesting, send me a note. Happy to talk more.
That's good. Well, yeah, I want to thank you again, you know, for your time. Very interesting, you know, project you're working on with Fascia, and yeah, I think we're all very eager to see, you know, like what direction this goes. It's still pretty early stage, but it seems really, really promising and seems to fill like a pretty big unmet need in the field for, you know, at-home sleep monitoring. So glad you're working on it and continuing your work at MIT out into the real world, and definitely wishing you a lot of success. And thank you again for, you know, joining this event today. It was really good.
My pleasure. Thank you so much.
Bye.